like mini
nose.
Yeah, like
yeah, it's called
so
the
it's like
lymphatic
these like
system.
tunnels,
Yeah,
like these like train tracks, like that. Yeah.
You know about mRNA vaccines?
Yes, I do.
Can you tell me like what you think about them and what's the difference between like a normal vaccine?
Yes. So imagine if you have like a person, and then a person, and then that person, it is infected by like a type of virus. Let's just choose COVID.
Yeah, like COVID.
But when the person gets injected by mRNA vaccines, that means the mRNA vaccines, they come. Imagine there's like this immune cells. That means the mRNA vaccine, they come to it, and then they ask the immune cells that they can make antibodies, or it's gonna make it dead. Or it's gonna die. So the immune cell does it, and when it creates the antibodies, they don't just stick to this, with the immune cell, except they go out and then they hunt for the virus, and then they connect on its protein spikes, and then when the virus is trying to infect the cell, that means they won't come in. They were just like bouncing, so it's like the virus is like a person, and then
it can't connect.
It can't connect because of the antibodies. It's like that the antibody, they're like some sort of spring, and then it's like a wall, and then the virus can travel through the wall. But then there has to be no items in it, and then the spring is like bouncing it back.
Yeah, that's pretty much like it. So I understand. When the mRNA, like a cell, like the mRNA, but remember, mRNA is different from DNA, and RNA is different from DNA, and the mRNA actually means messenger RNA. Yeah, and then so there's like, you know that there's like T in DNA, like T in DNA. It's actually replaced with uracil. RNA, yeah.
So deoxyuracil.
No, like A, G, C,
deoxide
and T. Like, is it A, G, C, and T?
Deoxide
ribonucleic acid is actually in RNA. It's ribonucleic acid, but instead of T, it's like in DNA is
messenger ribonucleic acid.
Yeah, like messenger ribonucleic acid. So like in RNA and mRNA, there is like in normal DNA, there's C, G, A, and T.
Yes.
But in RNA, it's C, G, A, and uracil instead.
So it's okay.
So the cell, it will use that information, that mRNA, and then it will make protein spikes. And those protein spikes are like those ones you see on images online about COVID and stuff. And then what happens next is that the cell will release those protein spikes, and then immediately, but they're actually harmless. It's not like we're injecting stuff that's actually making COVID come. That's way more dangerous. But we could do that, but it does more harm than good.
Test subject. Well, probably from a dead person, or that would be scary.
Yeah. So what happens is, after that comes out, then the immune system will immediately, oh, this is a virus, because it knows from that thing, from like
from the messenger RNA protein. So if it gets injected, that means the messenger.
I thought that the mRNA actually makes the spikes. Wait. Things like this. So the mRNA goes in the human body, it goes inside a cell, it makes the spikes, and then the immune system, it detects the spikes and it makes the antibodies, and then this is why it's like a white lie about you know, like those things like lying for a good reason, right? You know, and then what happens is that the protein spikes, it's kind of like a virus, right? And then, but it can't do any harm. And then the antibodies, they think that the protein spike is a virus, and then nothing really happens except that there's some B cells, and then by the time you get COVID, which hopefully you do not after you got the mRNA vaccine, then immediately the memory cells will immediately destroy it because of the trickery
so
that we done.
like you have like this, like imagine if you got a bleed, that means tons of bacteria come
like a
inside.
bleed.
Yeah, then
I once had those like
yeah,
tons of
that
times.
means so first let's skip all the way. So like first there's gonna be a dendritic cell, just but it's not gonna be the start of dendritic. So when you have a bleed, you immediately the dendritic cells will come. No. So first, but dendritic cells, there's like this hidden tunnels on the way. So it's like,
is it called the?
so it's like lymph nodes.
It's called
So
the
it's like
lymphatic
these like
system.
tunnels,
Yeah,
like
it's
these like train tracks, like that. And then we have the dendritic cell is looking for a helper T cell, but because there's like, because imagine if one of the helper T cells is
I know what this
named COVID, and then it's named COVID. That means the dendritic cell.
We look for that COVID T cell, right?
Yeah.
That's right.
Yes, and then it will come to that bacteria. Then it will come to that, and then it will activate it, and then it will start duplicating, and then it will split up into like two groups. So it's like that.
One will
one will go for to fight the virus, and the second will for the B cells. Yes, and then at the virus, and then imagine the first yes. And let me just skip all the way. So when the bacteria is like dead, that means some part of your immune cells they immediately die. But some helper T cells and B cells they turn into memory B cells, and they'll just so the memory helper T cell they will guard the place where the bleed was, making sure that same bacteria isn't there, and also a few antibodies will pump out.
So the memory B cells they will pump out antibodies still, but at very
like
low or no
antibody.
rate. The same antibody
very
at
low.
very low or no rate.
Very low, and then if that virus comes again, they'll just completely be obliterated by the tons of things.
And also, I want to add a tiny bit. Do you know why there's there's actually no helper T cell in my veins right now, or even in your veins, called COVID. Why? Because that's say you have billions of helper T cells.
But do we have helper T cells in our body?
Of course, right? Helper T cells everywhere basically. And then what happens?
But I have a question. Why there's these blue things?
I think they're veins.
So here you can't see these blue things, but when I do this, they're really seeable here and here. Yeah, but what are they? I don't know what they are.
Probably they're blood vessels or things. So I'll tell you why. It's because of genes. Imagine if we had the same genes. I would look like you, and then except for the scratches and stuff
and also fingerprints.
Yeah, fingerprints especially because.
Yeah, but can I see your fingerprint?
Yeah, different, right? Yeah. So
but one's circle and circle and circle and circle. Can I see one?
My one is circle and inside a circle, and then one is this curve. Yeah. So it's very, very, very complex. No two people have the same fingerprint. No one has the same fingerprint. But if we did,
then
one in the blue
and,
moon, basically.
And also, some people they have the same identical fingerprints here. Yeah, yeah, like my one, because yes, and then sometimes because I have a laptop and I put like this fingerprint sensor,
Oh, yeah.
which it will detect my fingerprint.
Oh yeah.
Yeah,
I
but
also saw that.
yes, but actually people, I think there's like there actually many more fingerprints like this. So people like go inside.
Oh,
Yes,
how can that happen?
yes,
Wait,
but also check your fingerprint. My one is like a circle and circle and circle.
can't really describe
circle,
it.
circle, circle.
You need to like have like
Yeah.
Yeah, so happens is that like if I look like you, then there'd be no variation. You know what? It'd be very bad if you had no variation. Like let's say
Because our
let's
mom
say
and
based
dad
on
will
our
get confused, right?
yeah like
Wakey, and then
No, which are you? No, I forgot to brush my teeth and then yeah, it'd be very confusing.
No, I forgot to brush my teeth and then
It'd be very confusing.
Huh?
And that's not the only bad thing. You know what the bad thing is? Sometimes we need different people for different things. Let's say we all had this gene which made us a bit weak. Let's say, like, it's not that we all have that. Let's say we have a gene that makes us a bit weak and it's harder to get big muscles. Then how could we weightlift, or how could we lift? How could even cavemen like make sticks or something? Let's say like make axes. How can they do that?
So first we just go to a tree and then we just and then like snap and then we could just and
it's not really good. So basically, we have to be different, and that's why like it's really good to be different. Like sometimes you like to do the piano, and I like to do sports and stuff.
Because sometimes we look identical.
Yeah, a bit identical.
Yeah, a bit identical except
for the scars, especially that one here.
Yeah. We look identical, but what people said that if you look identical when every day what parent said that if the kids look identical, that means Vessel put their labels like Wiki, like my name is Wiki. That means I get this paper and then I tape it on here and then it says Wiki and then and where they will put like Rainer.
Over here. So like this is starting to get a little bit out of hand, and that's why the T cells over here, one might be for COVID, one might be for influenza, and that's because there's different things. So wait, it's starting to get a little bit late, and it's close to our bedtime, so should we end the thing here?
Yes.
Okay, bye-bye.
Bye.
See you next time.